day, everyone. My name is Michael Cointel. So today I'm doing my internship at the Spark Foundation, Data Science and Business Analytic internship. So my task today will be on loan approval using support vector machine algorithm. So here is my Jupyter notebook. My my task today will be predicting a loan approval model. So this particular task is going to I'm going to use some variables, some independent variable from the individual, from a customer, to predict whether the customer is due for loan, whether the customer can be given a loan in the bank. So this particular project is used by commercial bank, financial tech, other online or different loan different companies that give loan to their customers. So they have a particular data set here, which is a customer data set. So I'm going to use it to predict whether the customer will be given a loan or not. So this particular process is rigorous. It's rigorous. So if they are doing it manually, so if the bank staff is going to do this manually, it's going to take a lot of time. Going to consume a lot of time. But with my model, after building my model, with my model, you can predict whether a customer should be given a loan or not. So this, instead of this thing that the task that can take you a lot of hours, you can achieve it under a second, within some seconds, under a minute, you will achieve it. So the model will run it for you. You are going to insert this data, and the model will now give you the outcome, whether the person should be given a loan or not. So here we go. This is our data set. I'm printing out first 5 rows. So here is our statistical measure. So our counts, we have 614 data set. Why our mean here is 5,403, and our standard deviation is 6,109. So our maximum is 81,000. So if you're looking at this, under this applicant column, applicant income. So if you're looking at this particular data set, you notice that it contains a lot of outliers, a lot of outliers. That our maximum is 81,000, and our 75 percentile is just 5,790. Why our maximum is 81,000? So the range is quite very big. It's very big range. So what we're going to do, we're going to work on our data set. We're going to remove the outliers. We're going to remove any outliers so that our model will work perfectly. So we are checking whether there is no value. As you can see, there is no value in the gender column, dependent column, self-employed. So we're going to drop all these null values. But you can decide to, instead of dropping it, you can decide to use other methods to fill it. So but in this video, in this task, we're not going to be doing that. But in our subsequent tasks, I might do it, but not for now. So I drop my null values. So this is the data set that is remaining. So I'm removing 134 values. So as you can see here, there is no there is no our data set doesn't have any null values again. So looking at our loan status contains values like y and the n. So the y means yes, that the loan is approved. Y n means no, that the loan is not approved. So what we're going to do, our model only need a numerical value. So replace we're going to replace all this y and n with 1 and 0. So our y will be replaced with 1, which is yes, and our no n will be replaced with no. We will replace it 0. So this is it here. As you can see, we have replaced it already. So we are displaying our dependence variables. So we notice that it contains a different data type, which is 3 plus. 3 plus is not a numerical value. Sorry, it's not an integer. It's not an integer, which means it's going to affect. It's not an integer. It's not a float. It's going to affect our model. So we need to replace it. So we are replacing any value that has 3 plus. We are replacing it with 4, so that our model will be able to consume our data. So as you can see, we have changed it. So here we are doing data visualization. So the essence of our data visualization, we want to, if you look at our data set here, there are these columns that contains text values like gender, married, marital status, education. So we want to check whether all these particular columns, whether they have an effect to our model. So whether they have an influence in the outcome of loan approval, whether the loan will be approved or not. So that's what we're going to do. We're going to use data visualization to check how efficient, how influence it carries. So if you look at here, we are comparing our education and loan status. So as you can see from the chart below, from the chart on the screen, that graduates are given loan more than non-graduates. So it means that if you're a graduate, you have more tendency to be given a loan than a non-graduate. Then marital status and against loan status. So from here you will see that married people, married customer are given loan more than those that are single. So probably it may be because um a married person is more responsible, and somebody that is married has a partner, which means they can come together and decide to pay off the loan and pay off their debt. So that's maybe one of the reasons. So from the model, from the our data set, married people are given loan more than those that are single. So gender or male gender are given loan more than female gender. Then self-employed, it means that those that are working under a company has more chances to be given a loan than those that are working on their own. Then property area, so semi-urban property, they are giving semi-urban are giving loan more than those in other property areas. So what we want to do here is what we want to do here is that we want to remove all these text values and replace it with numerical values so that our model will be able to use it. So under gender, we're working on gender, marriage, education, self-employed, property area. So we're removing all those. numerical values. We are removing all those text values. Excuse me. So as you can see, our gender, we have changed it. Um, our marriage, education. So we have, as you can see, there is no text values here. So all we have here now is numerical values, and our model is going to use it. So here we're going to detect our outliers. We're using bus plots to visualize, to detect our outliers. So it means that values that are above 10,000 are more are acting as an outlier. So we are using a statistical method which is interquantile range to detect our outlier. So as you can see here, our upper bound is 10,343, while our lower bound is minus 1,570. So it means that if a particular value is above 10,343, which is upper bound, it means that it's an outlier. And if it is less than minus 1,570 is an outlier. So here we are removing our outlier. Here we are removing our outlier. So after removing our outlier, we now have 480 data sets. So here we remove 40 values. So 40 values were removed as an outlier in our data set. So these are fall under our outlier. As you can see, under applicant income, you see 12 12,840, 12,550. So these are classified as an outlier, and those are the ones we remove. So we are still doing another statistical measure. So looking at the applicant's income again, after removing the outlier, you notice that our mean now is 4,178, which is moderate now compared to what we have before. What we have before was 5,000 and something, and our standard deviation previously was 6,000 and something. But currently, our standard deviation now is 1,958, which is moderate now, and our maximum now is 10,139 instead of 81,000. So that's it. So we are dividing our data set into dependent variables and independent variables and dependent variables. So we are dropping the loan ID. We don't need it. I'm also dropping the loan status. So we now have X variables and Y variables. So this is it. So we're going to split our data set. We are splitting our data set into two, which is training set and test set. Which is so our trend set is going to take 80% of the data, while our test set is going to take 20% of the data. So as you can see from here, so our trend set is 352, while test set is 88 data points. So here we are using support vector machine to train our model. So we train our model. After training our model, we predicted the train data. So the accuracy was 70%. So the accuracy of our trained data was 70%. So we also predicted our the test data. So the test data here is like a new variable. So it's like a new variable that we did not use to train our model. It's still new. So after that we got 69%. So which is quite good. So here again we're going to build a predictive system. So here you put in the values, all the values here. Like if you come now, you put your gender, your marital status, dependent, education, self-employed. So you're going to put in all the values. So after that, you run this cell, and it's going to tell you whether you are approved for a loan or not. So for this particular data, is the loan is approved. So for this one, the loan is approved. So this this predictive system, we can decide to put it in a nice front end design, so that you can input it and it will work perfectly. So it's just because of the Jupyter notebook, that's why it is in this format. So that is all I have for my video. So if you have any question, you comment in the comment section, or if you have any contribution, you also comment in the comment section. I thank you so much for paying attention and listening to my presentation.